this example, we must use measured quantities in a calculation to determine the concentration of a hydrochloric acid solution. The concentration will be calculated using this formula, in which C stands for concentration and V represents volume. The problem statement tells us the concentration of the sodium hydroxide solution and the volume of the HCl solution, so we need to determine the total volume of NaOH that is added to the HCl solution. To obtain the total volume of NaOH added, we need to measure the initial and final volumes in the burette and take the difference between them. As we solve this problem, we must express the measured and calculated quantities with the correct number of significant figures. To determine the total volume of NaOH added to the HCl solution, we first need to measure the initial and final volumes of solution in the burette. Let's consider the initial volume first. In this situation, volumes are measured at the bottom of the meniscus, which is highlighted by a dashed line. We can see from the bottom of the meniscus that the volume of sodium hydroxide is between 10.3 and 10.4 milliliters, so the first three digits of our answer will be 10.3. The burette markings allow us to know three certain digits. Remember, the first significant digit rule states that the last digit should be estimated. In this diagram, the dashed red line looks slightly higher than halfway between the 0.30 and 0.40 marks, so we can estimate the volume to be approximately 10.36 milliliters. We can measure the final volume in the same way. In this second diagram, the volume, again measured at the bottom of the meniscus, is highlighted with a red dotted line. This line indicates that the volume is between the 0.80 and 0.90 milliliter markings on the burette, so the first decimal place in the final volume is 8. To determine the second decimal place, we will estimate the position of the bottom of the meniscus in relation to each of these markings. The dotted line appears to be just below the 0.90 milliliter marking, so we will estimate the final volume to be 0.89 milliliters. Now that we have measured the initial and final volumes in the burette, we can calculate the total volume of sodium hydroxide used in this experiment. To do this, we take the difference between the volumes before and after dispensing the sodium hydroxide from the burette. Subtracting 0.89 from 10.36 gives 9.47 milliliters. Remember, once we have calculated any numerical value, we need to consider how many significant digits this value should be reported to. For addition and subtraction operations, the calculated answer is expressed with the same number of digits beyond the decimal place as the quantity that has the smallest amount of digits beyond the decimal place. Looking at the initial and final volume measurements, both of these numbers contain 2 decimal places. Therefore, the calculated value must also contain 2 digits after the decimal point. In this particular example, the value already contains the correct number of significant digits. However, this will not always be the case. Now that we know the total volume of sodium hydroxide, we can calculate the concentration of the hydrochloric acid solution using the formula that was provided. We know that the concentration of NaOH is 0.10 moles per liter, and the volume of the HCl solution is 25.0 milliliters. We have just calculated the total volume of NaOH to be 9.47 milliliters, so we can substitute all of these values into the formula. By performing the arithmetic, we obtain an answer of 0.03788 moles per liter for the concentration of the HCl solution. We must now determine how many significant digits to report in our calculated value. For multiplication and division, the calculated value is reported to the same number of significant figures as the value with the smallest number of significant figures. Let's consider the number of significant digits in each of the values used to perform the calculation. The concentration of sodium hydroxide, 0.10 moles per liter, is known to two significant figures. The volume of sodium hydroxide, 9.47 milliliters, and the volume of the hydrochloric acid solution, 25.0 milliliters, both contain three significant figures. Therefore, the initial number, which contains the fewest significant digits, is the concentration of sodium hydroxide, with two significant digits. This means that the final answer must also contain two significant digits. As calculated, the answer 0.03788 moles per liter contains four significant figures. Therefore, to obtain two significant digits, the final number should be rounded off at the second significant digit. In this case, the digit following the 7 is greater than 5, so the 7 will be rounded up to an 8. Therefore, the final answer is 0.038 moles per liter.